Again, an important point. Why we need ELT is because in order to identify the latest record, you have to store all the record at some place, because this is a transactional system. It will keep moving. Hello friends, welcome to ITK Funde, your own channel where we make IT interesting for everyone. And in this video, we will understand some basic data pipeline design patterns. Following up from our previous video which covered the basics of data pipeline, in this particular video we will go a little deeper and try to understand the various components of data pipeline and then some design patterns. So in this video we'll start with understanding the basic components which creates a data pipeline, and then we'll understand these basic design patterns which are used very commonly in designing data pipeline. ETL pattern, ELT pattern, and obviously change data capture. And if we have time, I will also try to cover one additional pattern which I think would be useful for you to know. So without further ado, let's get started. So friends, let's understand some basic components of data pipeline. So data pipeline has two main types of designs. One could be a batch data pipeline which only processes the data in batches, and the other one is streaming data pipeline which could be real time. We have talked about this in detail in our data pipeline basics video, so go check that out. So yes, data pipeline could be a batch data pipeline or a streaming data pipeline, but basically data pipeline, what it exactly consists is a DAG design, which is directed acyclic graph. Now if you would have read the graph theory in maths, any directed acyclic graph has two main components. One is the node, the actual node, and the other is the edges. So in acyclic, understand this word acyclic. So what is cyclic? Cyclic is which can go into cycle. So acyclic means that in this particular design, you can only go from point A to point B, and from point B to point C, and from point C to point D. But at no point you can go back from point D to point A. So it is always from upstream to downstream. It can never happen that a downstream can feed data back to upstream. So this kind of design is called as directed acyclic graph. So whatever you see in your data pipeline, you basically design DAGs, directed acyclic graph designs. So in in a later section we will understand how this is designed, but this is a very basic concept. You need to understand this. So DAG consists of source and sink. Name is very self-explanatory. Source is the point or the place from where the data originates or where the source data is stored, and sink is where it is sent to, where it is processed and sent to. That is what is called as sink. So your point A to point B will go via some ETL process. Okay, so this particular thing is your source and this is your sink, and this in place ETL, and ETL is nothing but a subset of data pipeline, so don't get confused. So a data pipeline can combine a multiple ETL designs, which eventually is nothing but a kind of a DAG, obviously if you are going by using the DAG approach. Okay, but then there are pipelines which does not fit into a DAG pattern, because then we do send data back here. Okay, so those kind of patterns are not called as DAGs. Okay, but generally you will have your DAG design pattern. So your ETL is your subset of your data pipeline, and this ETL will take the data from the source and put it in the sink. So very basic. Now we have understood some basic concepts and the components of data pipeline. Now we'll directly jump into specific design patterns. So let's start with our very first design pattern, which is ETL, extract, transform and load pattern. A very traditional pattern. We have discussed it on numerous occasions, but let's go a little deeper and understand how it correlates with directed acyclic graph or a DAG design. So as you can see, I have created this design pattern wherein on the left we have the source in blue, and then this particular source is directly mapped inside this DAG. So this could be somewhere in your staging area where you take this whole source data and place it somewhere within your this DAG design, and then take this data and then apply some transformation in green, and again from this particular source you can again transform something, and then you can combine these two transformations and put the data into the sink. So there could be a valid question that why can't we directly go from here to transform, why we have to do this additional thing. This could be possibly because these are your operational systems which are feeding somewhere to the business applications. You don't need to impact these, you cannot impact these because these are running your business, while this is your thing where you are doing your data science projects, your reporting and all those things. Okay, so if you are hitting directly here all the time, then that could be a problem for this system if it is not having enough resources. So that's why general practices, we try to pick it, keep it in a landing area, in a staging area, and then from there we take it further. So this design is very common, and again the design patterns which we will discuss today are very closely related to data warehousing design patterns. There could be number of other design patterns, but we are focusing very specifically around data warehousing designs, wherein we load the data in a data mart or in a data warehouse. It could be on-prem or it could be on the cloud as well. So just keep that thing in perspective. Again, this whole DAG design, it could be a Python code which you have developed, okay, but once this DAG has been created, okay, this DAG design has been created, then it could be orchestrated as well. So orchestration means scheduling this DAG and orchestrating it so that it is running at a specific interval at a specific time. Suppose if it is a batch design, then maybe it needs to run every 2 hours, every 3 hours, or maybe overnight. So in those cases you can orchestrate it. There is a product called as Apache Airflow which is specifically used for such things on cloud. But yes, if you are using a product, so in a product, if you are using a ETL product, most of the times that particular ETL product in itself will have those scheduling or orchestrating capabilities. So yes, a very straightforward design, a traditional design, but very effective, still used a lot. But yeah, this is our ETL design pattern. So now let's move on to our second design. So friends, let's discuss the second pattern, which is ELT, extract, load and then transform. This is one of the most prominent design patterns as far as cloud computing is concerned, or as far as loading data into data lakes is concerned. This is now becoming the de facto design slowly and gradually, because this gives us a lot of flexibility which we will discuss. So if we talk about the design, the data is first extracted and directly loaded from source to sink, from where it goes into the staging layer. Okay, so the unique thing about ELT, extract, load and transform, is that the focus is to maintain the raw state of the data and store it as is, and then apply any transformation in the second DAG. So unlike the ETL pattern where everything was done in one DAG design, in here we have two different DAGs. One would be EL, which is extract and load, and there would be a separate transformation DAG which we will create once the data has been loaded into the staging layer. It could be any staging platform which you can use. So in this case your raw data is stored here, and then whatever transformations you do after that is mostly SQL query transforms. What does that mean is that you have stored your raw data up till here, and after that whatever business logic, whatever requirements you want to show maybe in a report, those kind of logics and transformation you apply here using SQL queries, and eventually then you load data into specific data mart. So now if you are if you want to know what is a data mart, what is a data warehouse, we have separate videos. I'll put the links in the description so you can check those out. But yes, this is extract, load and transform. So now let's understand some features of this design. So as I said, very good feature if we are trying to implement a data lake solution, because in data lakes we retain the raw data within the data lake and then do the transformation. So this pattern is used a lot there. Then again, another pattern which we are discussing after this, change data capture. So this could be a precursor design, or this could be a parent design on top of which change data capture happens. So CDC is built on top of ELT design pattern as well. As we discussed, SQL queries are used for transformation, but the downside of this is that it needs a lot of computational resources and power when you are implementing this design, and that's why we use cloud solutions as far as implementing ELT is concerned, because if you are using this within on-prem data warehousing solution, then it could be a bit costly for you. So take for example, if you are just implementing it into a GCP solution, then you can load the data maybe somewhere here, and then it could be your Cloud SQL instance, for example, or MySQL instance, for example, and from here you can have your queries and data getting loaded into BigQuery. And as you know, BigQuery is a very good platform, very cheap platform, but with massive processing power. And yes, the last point is again, this is very well suited for our cloud-based solution. So let's move on to our third pattern. So friends, the third pattern in our list is CDC, which is Change Data Capture. As we discussed previously, it is based on our ELT design, what you can see in this diagram as well. Change Data Capture enables us to track and record the latest changes happening at the source layer and store it in the data warehouse, and then always get the latest version of that particular record. Now there are some products automatically available in the market which does this change data capture for us, but if we have to design it, this is the design how we do it. So if we talk about products, then there is Oracle CDC, there is Attunity, there are multiple products which reads the database logs. In specific, if we talk about Oracle, there are redo logs. All those kind of logs can be read to track the changes. But how exactly the changes are tracked, that's what we are understanding in this particular design. So again, this is the ELT design. So this is our EL DAG, and then this is our transformation DAG. Okay, so the data, whenever there is any change on this particular source system, that particular change is recorded, and then that particular change is moved into the staging layer. So suppose there is a record, and that particular record version N is the current record which needs to be pulled into this particular data warehouse staging layer. And again, an important point, why we need ELT is because in order to identify the latest record, you have to store all the records at some place, because this is a transactional system. It will keep moving, it won't stop. So this particular record will get updated to this one and then the latest one. So how you will identify which is the latest one out of these three? So in that case, you have to record these three records is somewhere in your staging layer, so that you can derive which one is the latest record. So suppose there is there is one particular record which gets inserted, so it will be captured and then it will be stored in the staging layer. Suppose after some time an update comes for that particular record, so then that particular record will again goes into this particular flow, and then will be recorded as version N plus 1. So the original version was N, and then the next version which will come will be N plus 1. And then in the staging layer, we will also capture the timestamps, which is denoted here by TS. So to create a unique identity of that particular version along with the timestamp with which it has come into the database. So the original version was version N, then there was suppose a new version, new update which has come in, which is a change data. So again, that will go as N plus 1. And then in the transformation layer, you will run a query, because as we understood, these are in ELT design pattern, we run SQL query transforms. So in there, you will find that which is your max version. So you will run a max query, and then that particular max query will identify that, okay, this is the version which is the max version, and that particular version will be sent to your data mart. So this is how the change data capture mechanism works on top of our ELT design pattern. So now I think I have covered the three design patterns, and let me just share the last one which I discussed. I still think we have not had such a lengthy session, so let me try to bring that particular pattern as well, and let's see how much we can cover for that. So friends, fourth and the last pattern is EtLT pattern, which is a sub pattern of our ELT design. And here the T is nothing but a mini transform which we can apply early on in the data pipeline to have certain benefits. So it is very similar, but again, as you can see, there is a mini transform which we can apply right at this particular stage to do certain activities which if done earlier in the data pipeline could have certain benefits. So what activities it contains? First and foremost, your business logic is completely disconnected from this particular transform. Everything will happen at this particular layer using SQL query transform. So no business logic will be done here. This particular mini transform can help you in certain ways. For example, deduplication, data deduplication. So suppose from source you have multiple copies of similar data coming. So data deduplication is a technique where you remove these excessive duplicate copies of the data. And if you do it right here, you will avoid garbage to go ahead in your data pipeline. So if you can do it right here, then obviously you are first of all reducing the volume of the data or the amount of data which is flowing ahead in the pipeline, and again you are also performing data deduplication. Secondly, if you have certain URLs which are coming in, you can parse the parameters of those URLs right at the initial stages instead of going at the end and doing somewhere here, okay? Because this is unrelated, this is not related with your business logic. You just need to parse the URL and see whether the parameters are valid or not. One more very important aspect of this particular sub pattern is masking or hiding sensitive information. So suppose if you are loading the data on the cloud and you are under GDPR compliance, which restricts personal information to be shared, then that particular compliance checks could happen right at the start of the layer instead of realizing it at the very end. So that kind of data, or suppose if you want to mask somewhere the banking data or some credit card information, all those kind of masking or securing of data or hiding of that sensitive data could happen right at this particular mini transform. And last but not the least is it might also give you some performance benefits. It could help you reduce the latency because you might filter out certain garbage or certain data which is not at all required. So yes, it is a sub pattern, and I thought it would be helpful for you to learn this. So this brings us to the end of this video, guys. Sorry if it was a long video, but I tried covering these 4 patterns, starting with our ETL traditional design pattern, then moving to ELT, which is extract, load and transform, and then the third pattern was change data capture, and lastly EtLT, which is a mini transform on top of your ELT design pattern. So friends, this brings us to the end of this video. I hope you liked it. If you did, please hit the like button, hit the subscribe button and the bell icon to know when I upload my next video. And until next time, please keep learning, keep sharing all the knowledge, and yes, keep hustling. Bye for now.